This meeting is being recorded.
The next topic that is introduced in our Chapter 15 Chemical Equilibrium worksheet is the Le Chatelier principle here. And this is something that you should know well regarding reactions that establish chemical equilibrium. So in this table below here, we can see the three main concepts within this principle. So first, dealing with concentration of reactants and products. We can see that there's an initial concentration in our system here. These are our reactants, and then this yellow block is our product. So some substances react. We can see that more product is produced. And we can see that if a substance such as a reactant is added, that will cause a shift and a reestablishment of equilibrium here. So again, our systems will always try to reestablish equilibrium if there's some kind of external stressor on our system. So adding or removing a reactant or product could be that type of stressor that causes, if we add reactants specifically, so over here, oh, that's what we saw. We re-added this reagent here. We see a shift to increase product. The same thing would apply, say we removed some product, we would also shift towards products to reestablish equilibrium. Another concept within this principle is that of pressure. So pressure and volume are inversely related. So if we have an initial volume here and we increase pressure, we're going to see that we decrease volume. So again, increasing pressure would decrease volume. They're inversely related. And as long as we remain at constant temperature, we will see that we would have a shift to the direction that reduces the number of moles of gas, so the smaller volume. So we'll see some of these examples below in some practice problems. The last concept here has to do with temperature. So whether we have an endothermic reaction where we think of adding heat to a reaction, or an exothermic where we think of heat being released. So in endothermic, we think of heat as a reactant. And then in an exothermic, we would think of heat as a product. So depending on whether or not we increase or decrease temperature, we'll see a shift in reactions accordingly. So again, we want to consider heat as either a reactant or product. So let's take a look at sample exercise 14 here. So here's our reaction at the top here that has established equilibrium. We can see that it has an enthalpy value of positive 87.9. So this is an endothermic reaction, and we can consider heat over here as a reactant. So let's take a look at if we added or removed a reagent, what would happen. So we want to remove some of this over here. So we lower the concentration. We're going to see that we're going to get a shift to the right to increase products because we've removed some of that product. In part B, if we decrease temperature, that's like removing heat as a reactant. So we would see a shift in the opposite direction. We would see a shift to the left to increase reactants. Let's see here in part C, the volume of the system is increased. So we can go to the larger number of moles of gas. So that would be a shift to the right. And we would increase the number of moles of gas because we increased our volume. And then in our last scenario here, we're going to add some of our product here. So we're going to see again a shift towards the left, towards reactants. Let's take a look at the next practice exercise here, number 15. We have our reaction here. N2O4 gas turns into 2NO2 gas. So we have 1 mole here, keep that in mind, 2 moles here. We have, again, a positive enthalpy value. So this is another endothermic reaction. So we'll put heat over here as a reactant. And let's see what happens if we were to add N2O4. So that's a reactant. We're going to shift to the right towards products. And then we have if NO2 is removed, so that's a product. So again, we're going to have the same shift. Because we remove product, we're going to create more product to reestablish equilibrium. Part C here, we're going to increase the pressure by the addition of N2 gas. So since we're not increasing or decreasing volume, we're just adding an inert gas that's unreactive. So we're not going to see any shift here when we do that. So again, this is an inert gas, it's unreactive. We're not changing volume, so we will see no shift. Let's take a look at if the volume was increased. So let's go back up here. If we increase volume, we're going to shift to the larger number of moles. So we're going to see a right shift towards products. So we'll say larger number of moles of gas. And then if the temperature is decreased, we'll take into consideration again heat as a reactant. So this is endothermic, so we're decreasing our reactant. So to reestablish our equilibrium in our system here, we would see a shift towards the reactants. And we'll call that a left shift.